Hi, my name is Shahroz Ahmed, and in this video I'm going to discuss a topic of IB Maths standard level, and the topic is sequence and series. So we are going to discuss the arithmetic sequence and the geometric sequence. So here is the topic that we are going to discuss: sequence and series. So let's start off with the arithmetic sequence first of all. So arithmetic sequence. So arithmetic sequence is such a sequence of the numbers where there is a common difference. For example, if I write a sequence over here, 4, 7, 10, 13, 16. So you can see there's a common difference between all of these numbers. If we subtract 4 from 7, there's a difference of 3. 10 minus 7, that will be 3. 13 minus 10, that will be 3 as well. 16 minus 13, 3. So such a sequence is called the arithmetic sequence. Alright, now this is the common difference. This 4 will be considered as the first term, and if we have to find out the fifth term, sixth term, or any other term, that term will be called the nth term. Okay, so nth term. Now we have a formula in order to work out the nth term. So let's suppose we want to find out the fifth term. So this is the fifth term. 1 2 3 4 5. 16 is the fifth term. So in this sequence our nth term will be the fifth term. So I'll say that my nth term will be equal to a subscript 5. Now in order to find out the nth term, we have a formula. So the formula is a of n equals to a1 plus n minus 1 times d. So a1 is the first term, n are the number of terms, and d is the common difference. So the first term is 4. The total numbers of terms are 5 because we want to find out the fifth term. So our n will be equal to 5. I'll write it here. N will be equal to 5, and a1 is equal to 4, and the common difference that we have is 3. So the fifth term will become equal to the first term, that is 4, plus n minus 1, that is 5 minus 1, times d, that is the common difference. So in this way we'll work out our nth term. So that would be 4 plus 4 times 3. That would be equal to 16. So 16 is the nth term. As you can see over here, this is our fifth term, that is equal to 16. So this is how we can use this formula to work out the nth term of our arithmetic sequence. Now there is another formula that we have to discuss over here, and that formula is used to find out the common difference. Alright, so let me just erase it. Alright, so this is our original sequence. So I'll remove this 7, I'll remove this 10, I'll remove this 13. Now we do not know these three terms in between the first term and the fifth term. This is the first term and this is the fifth term. So we do not know the term in between them, so we are not able to find out the common difference by just subtracting the two consecutive terms. So in order to do that, we have to use a formula for the common difference, and the formula is common difference is equal to the last term, like the bigger term. I'll consider it as the m, like a of m, and I'll consider this as a of n. So the bigger term minus the smaller term, it's like a of m minus a of n divided by m minus n. So now this is the first term, so over here n will be equal to 1. This is the fifth term, so over here m will be equal to 5. So what I'll do is I'll write it as a of 5 minus a of 1 divided by 5 minus 1. So a of 5 is 16, a of 1 is like the first term, that is 4, divided by 5 minus 1, that is 4. So 16 minus 4 is 12, so it's 12 over 4. So in this way we can find out the common difference, that would be equal to 3. So d will be equal to 3. So this is the formula that you can use in order to find out the common difference if the consecutive terms are not available. Alright, now after this one, let's move on to the formula for the sum of arithmetic sequence. Let me just erase. Alright, so for the sum of arithmetic sequence, I'll just write that sequence once again. So it's 4, 7, 10, 13, 16. So this is the arithmetic sequence, and we want to find out the sum. So the formula for the sum of arithmetic sequence is Sn equals to n over 2 times 2a1 plus n minus 1 times d. So in order to find out the sum of the arithmetic sequence, we want to know the number of terms that we have to find the sum for. We want to know the first term and the common difference. So for this sequence, let's suppose I want to find out the sum for all of these terms. So I have the total terms equals to 5, and my first term will be equal to 4. The number of terms are 5, of course, so d will be equal to 7 minus 4, that is 3. So I'll just insert these values over here and I'll work out the sum for the first 5 terms. If you want to find out the sum for, let's suppose, 100 terms, we can just put n equals to 100. Alright, so s of 5 will become equal to 5 over 2 times 2 times 4 plus 5 minus 1 times d, that is 3. So it'll be like 2.5 times 8 plus 12. So it will be equal to 2.5 times 20. So that will be equal to 50. So the sum of all of these terms will be equal to 150. It will be equal to 50. So this is the formula that you can use to find out the sum of the arithmetic sequence. Alright, so after that arithmetic sequence, now we have to discuss the geometric sequence. So in geometric sequence, we have a common ratio instead of a common difference. So in the arithmetic sequence, we have seen that within a sequence there is a common difference between the two consecutive numbers. Over here we will have a common ratio. For example, when I write a sequence, let's suppose it's 3, 6, 12, 24, 48. In this sequence there is no common difference because 6 minus 3, it is 3. 12 minus 6, that is 6. 24 minus 12, that is 12. But over here we have a common ratio. For example, if you divide 6 by 3, you will get 2. If you divide 12 by 6, you'll again get 2. If you divide 24 by 12, you'll get again 2. 48 over 24, again 2. So 2 is the common ratio in this sequence. So I'll write it as r equals to 2, and a sequence in which you see a common ratio, such a sequence is called the geometric sequence. Now in the same manner as of the arithmetic sequence, we have to work out the nth term for the geometric sequence, and for that purpose we will write down a formula. So for example, if you want to find out the nth term of the geometric sequence, the formula will be like this: an equals to a1 times r to the power of n minus 1, where a1 is the first term, n is the nth term, r is the common ratio, n are the number of terms. So this is how we can use this formula to work out the nth term of the geometric sequence. So let's suppose we want to find out this fifth term. So I'll write it as a of 5 equals to a1 times r to the power of n minus 1. So the first term is 3, the common ratio is 2, number of terms are 5, so it'll be like 3 times 2 to the power of 4. Now 2 to the power of 4 is 16, so 16 times 3 will give us 48. So here we have 48 as the fifth term. So this is the formula for the nth term. Now in order to find out the common ratio, if we do not have the consecutive numbers, so for that purpose I'll just show you the formula. Alright, so here we have the geometric sequence, and let's suppose we do not have this term, we do not have this term, and we do not have this term. We have only the first term and the fifth term, and in order to know the common ratio, we have to use a certain formula, and the formula will be r to the power of m minus n equals to am over an. So consider that this term is your an and this term is am, and as we know that m is the fifth term, so I'll say that m is equals to 5 and n equals to n is the first term, so n will be equal to 1. So r is the common ratio that we have to find out. So it'll be like r to the power of 5 minus 1 equals to 48 over 3. So it will be like r to the power of 4 equals to 16, and then we will take the root of 4 on both sides. So in this way we'll get r equals to 2. So this is the formula that you can use to find out the common ratio if you have not been given the consecutive terms. Okay, so after the common ratio we have to see the formula for the sum of geometric sequence. Alright, so for the sum of geometric sequence we have this formula: S of n equals to a1 times 1 minus r to the power of n whole divided by 1 minus r. So r is the common ratio, a1 is the first term, and n are the number of terms. So let's suppose we have a sequence that we want to sum up. So it's like 3, 6, 12, 24 and 48. So this is the sequence, and we want to find out the sum of the first 5 terms of this sequence, and we know that this sequence is a geometric sequence because it has a common ratio. So our a1 will be equal to 3, our common ratio will be equal to 2, like 6 over 3, n will be equal to 5 because we want to sum up the first 5 terms. So it'll be like this: S of 5 equals to 3 times 1 minus 2 to the power of 5 whole divided by 1 minus common ratio, that is 2. Alright, so it'll be like 3 times 1 minus 32 whole divided by minus 1. So the answer will become 3 times negative 31 over negative 1. So it will become negative 93 over negative 1, that will be equal to 93. So the sum of these 5 terms is equal to 93. Okay, now let's suppose if the sequence is an infinite sequence, infinite geometric sequence. So for such a sequence we will use another formula, and in that sequence, okay, the sum of the geometric sequence that is going up to infinity will be infinite if the common ratio is greater than 1. For example, I'll write a sequence, an example sequence over here. Okay, so we have 2 sequences here: 2, 6, 18, 54. So the common ratio for this sequence is 6 over 2, that is 3, 18 over 6, that is 3, 54 over 18, that is 3. So the common ratio is 3. And this sequence, for this one, the common ratio will be equal to 5 over 10, or 2.5 over 5, 1.25 over 2.5. So that will be equal to 1 over 2. So the sequence whose common ratio is greater than 1, the sum of this sequence will be infinite if this sequence is going to infinity. Okay, so the sum of this sequence is not possible if this is an infinite sequence. I'll write dot 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 in order to represent that this is an infinite sequence. This is also an infinite sequence. So the sum of this will be not possible because it will be equal to infinity. Now the common ratio, if the common ratio is less than 1, for example in this one the common ratio is less than 1, so this type of sequence will be possible. The sum of this sequence is possible, and for such a sequence we use this formula: S of n equals to a1 over 1 minus r. So we need the first term and we need the common ratio. So in this way we can work out the sum of geometric sequence. So this is it for the topic discussion. Now we'll see some practice questions in which we will see some exam related questions. So let's go on to that. Alright, so for the exam related questions I'm following this website, revisionvillage.com, that it has all the resources for IB Maths, and most of the students follow this website, so that's why I'm also following it. Okay, so these are all the exam related questions. So I'll do one easy level question, one medium level and one hard level question. So let's suppose we have an arithmetic sequence where the first term is 40, second term is 32 and the third term is 24, and we have to work out the common difference. That's quite simple. You will just subtract the first term from the second term. You can just see the difference between the two consecutive terms. So this will be your sequence: 40, 32 and 24. So the common difference will be equal to 32 minus 40, that will be equal to minus 8. So the answer for the first part is equal to minus 8. Now eighth term, in order to find out the eighth term, we will use the formula for the nth term of an arithmetic sequence, and the formula will be like this: an equals to a1 plus n minus 1 times d. So because we are looking for the 8th term, so it'll be like, I'll write it as u of 8 equals to the first term is 40 plus the number of terms are 8, so it will be like 8 minus 1 times the common difference is negative 8. So I'll get 40 plus 7 times negative 8, so it will be like 40 minus 56. So 40 minus 56 will be equal to minus 16. So minus 16 will be our 8th term. Okay, now after this one we will do part C, where we have to find out the sum of the first 8 terms. So for that purpose I'll use the formula over here for the sum of arithmetic sequence, and the formula is s of 8, or just write s of n equals to n over 2 times 2a1 plus n minus 1 times d. Alright, so the number of terms are 8, so I'll write it as 8 over 2 times 2a1, so it will be like 2 times 40 plus n minus 1 will be 7, and the common difference is negative 8. So it will become 4 times 80 minus 56. So my sum will become equal to 4 times 24. So 4 times 24 will be equal to 96. So the sum for the first 8 terms will be equal to 96. So these are the answers for part A, B, and C. It's quite simple. Now let's move on to some medium level question. Okay, so here we have a medium level question. It says the first term of an arithmetic sequence is 24 and the common difference is 16. Find the value of the 62nd term of the sequence. So we have the first term. I'll write the data over here. So the first term is 24. The common difference is equal to 16. The number of terms are 62, and we have to find out the 62nd term. So we'll just use the formula. That will be an equals to a1 plus n minus 1 times d. Okay, so a1 is 24. I'll shift my working over here. So a of 62 equals to 24 plus 62 minus 1, that will be equal to 61, and the common difference is 16. So from here I'll get my 62nd term. So it will be like 24 plus 976. So 976 plus 24 will give us the answer 1000. So the 62nd term is equal to 1000. This is 1000. Now let's see the next part. In the next part it says the first term of the geometric sequence is 8. The fourth term of the geometric sequence is equal to 13. Is equal to the 13th term of the arithmetic sequence given above. Okay. Write down an equation using this information. So in this one we basically have to write down the equation for the common ratio. Okay. So we have the first term of the geometric sequence that is equal to 8. We also have the fourth term that is equal to the 13th term of the arithmetic sequence. So let's find out the 13th term of the arithmetic sequence, and from there we will get the fourth term. And once we have the fourth term and the first term, then we can write down the equation for the common ratio. So u of 13 will be equal to the first term, that is 24, plus n minus 1, that is 12, the common difference, that is 16. So 24 plus 12 times 16. So 12 times 16 will be equal to 192, and 192 plus 24 will give us 216. So the 13th term is equal to 216. So now the 13th term is equal to the fourth term. So our fourth term of the geometric sequence will become equal to 216. Okay, now I'm going to write down the formula, that is r to the power of m minus n equals to a of m over a of n. Okay, so I'll consider this as my mth term, and this will be my a of n. So my m will be 4 and my n is equal to 1. So I'll write it as r to the power of m minus n, that will be equal to 4 minus 1, that is 3, equals to a of m over a of n. So a of m is 216 A of n is 8. So 216 over 8 will give us, it will give us some 27. But because we have to just write down the equation, so I'll just write it as 8r cube equals to 216. So this will be my equation for this information. 8r cube equals to 216. Now I have to work out the common ratio, so by using the simple calculation I'll work out my common ratio. So it's like r cube equals to 216 over 8, that will be equal to 27. Now when we take the cube root of 27, I will get my value of r. So my value of r will become equal to the cube root of 27. So r will be equal to 3. So 3 is my answer. Okay, so we are done with this medium level question. Now let's move on to a hard level question. Okay, so here we have a hard level question. It says the sides of a square are 8 centimeter long. A new square is formed by joining the midpoints of the adjacent sides and 2 of the resulting triangles are shaded as shown. This process is repeated 5 more times to form the figure on the right side. We have to work out the total area of the shaded region in the right hand diagram. So in order to do that, let's find out the area for the first figure, the area of the triangles for the first figure. So in order to find out the area of the first triangle, we have to write it. Okay, this whole length is 8 centimeter. This is the half, this is the half, so it will be 4 and 4. So the area of this triangle will be equal to half times 4 times 4. That would be equal to 8. The area of this triangle will also be equal to 8. So in the first figure, the total area will be equal to 8 plus 8. So I'll write down the area over here. For the first figure, it's 8. Now look at this second triangle, this one. In order to find out the area of this triangle, we have to work out this side first of all. So this, in order to work out this side, we will use the Pythagoras theorem. Like we have to work out this side. So this is 4, this is 4. So this side will become equal to under root 32. By using the Pythagoras theorem. So under root 32 means 4 under root 2. Now the half of this side will be equal to 2 under root 2. So like from this point to this point, it will be 2 under root 2. So in order to find out the area of this triangle, we will use this formula. 1 over 2 times 2 under root 2 times 2 under root 2. So it will become equal to 4. So the area of this triangle is equal to 4, the area of this triangle is equal to 4. So the area of the second set of triangles will be equal to 8. This was 16. In order to find out the area of the third triangle, we have to use again the Pythagoras theorem for this triangle and this rectangle. So in order to find out this side, we will have to use 2 under root 2 square plus 2 under root 2 square whole under root. So this will give length of 4. Now the half of 4 is 2. So for this triangle, the height, the base and height will be 2 and 2. So the area of that triangle will be equal to 1 over 2 times 2 times 2. This is the area for one triangle, but we have the two triangles, this one and this one. So it will become the area of one triangle will be equal to 2. For the two triangles, it will be equal to 4. So the next area will become equal to 4. Now you see we got a sequence. So we got this one by repeating for 5 more times. So it's like it's a third term, the first term, second term, the third term. From here, this will be our fourth term. This will be our fifth term. This will be our sixth term. So we have to repeat it for the sixth term. So n will be equal to 6 and a1 is equal to 16, and the common ratio, as we can see from here, the common ratio is equal to the second term divided by the first term, that will be equal to 0.5. And we have to work out the total area. So in order to work out the total area, we will use the formula for the sum. sum of the geometric progression. So the formula for the sum of geometric progression is a1 times 1 minus r to the power of n whole divided by 1 minus r. So we have to work out the first six terms, where the first term is equal to 16. 1 minus r is like 0.5 to the power of n, so n is equal to 6 whole divided by 1 minus 0.5. So I'll just put this whole thing into the calculator and I'll get the sum of the first six terms. That would be equal to 63 over 2. So 63 over 2 is equal to 31.5. So 31.5 centimeters square is the sum of the shaded triangles in the second figure. Now it says in part B, find the total area of the shaded region if the process is repeated indefinitely. So we'll use the formula for the sum of infinite sequence. The formula for the sum of an infinite sequence is S of n, or S of infinite, equals to a1 divided by 1 minus r. So a1 is the first term, that was 16, and 1 minus the common ratio was 0.5. So that would be 16 over 0.5, which will be equal to 32. So 32 is the total area of the shaded region if this process repeats itself for infinite times. So that was the hard level question for the geometric progression and arithmetic sequences combined. So I hope you got it, and thank you so much for watching. I just forgot to write on the unit, so it's 32 centimeters square because we are calculating the area. All right, so this is it. Thank you so much for watching.